In this example, we want to evaluate the integral of sine of t divided by the cosine cubed of t dt. In this case, we have a composition of two functions in the denominator. We have the cosine function being cubed, and we know the cosine function has a derivative that is negative sine, and so the derivative of our inside function is in our integral up to a constant, in particular that negative sign. So this suggests that we use a u substitution here, and we can let u be the inside function of that composition, which would be cosine of t in this case. Once we have u, we can differentiate that to get du, which we know is negative sine of t dt. And looking at our integral here, we see that we have most of this. We're just missing our negative sign. And so we can use that negative du is sine of t dt and make this substitution. And so our integral, when we substitute everything in, we're going to have negative du for the red circled part of the original integral, divided by u cubed. So we have a u cubed in our denominator. Of course, we can take our negative outside of our integral and rewrite u cubed as u to the negative third power. So we have the negative of the integral of u to the negative third power du. The antiderivative of u to the negative third power is going to be u to the negative second divided by negative 2, all plus our arbitrary constant c. And we can rearrange this a little bit. We know that our two negatives are going to become a positive, and we know that the u to the negative 2 we can move to the denominator and have it with a positive exponent. And so this simplifies to 1 over 2u squared plus c. Now the last step here is to go back to our original variable t, and that is done by replacing u with the cosine of t. And so we have 1 over 2 cosine squared of t, all plus our arbitrary constant c. And this is the value of the integral of sine t over cosine cubed t dt.